Hi, this is question 4 from the AQA Further Pure for January 2010 exam paper. The video is going to be split into 3 parts. The first part is going to be try, and then the second part of the video I'll give you a hint if you're unsure, and for the third part of the video I will go over the answer. So this is the try part of the video, so if you'd like to pause it and have a go at working out the answer yourself. Okay, this is now the second part of the video. In this part of the video I'm going to give you a hint as to how you can go about working out the solution. So we're asked to determine the 2 values of k for which this system of equations does not have a unique solution. Now what you need to remember is if I was going to write this in matrix form, if it doesn't have a unique solution, then my matrix is going to have a determinant of 0, because we don't want there to be an inverse to the matrix. An inverse of the matrix won't exist, I should say. So if it doesn't have a unique solution, we want to make the determinant of the matrix equal to 0. Part B then says that we need to show that this system of equations is consistent for one of these values of k, but is inconsistent for the other. So for one of the values, I want to show that the equations agree with each other, and for the other value I want to show in some way that they disagree with each other. Okay, so those are my hints for the questions. If you'd now like to pause the video and have a go at the question yourself, you can do that now. Okay, this is the third part of the question, and this is the part where I'm going to go over the answer to the question. I'm just going to make this a little bit smaller so I've got a little bit more room to work in. For part A, I'm first of all going to write this as a matrix equation. So for part A, I'm going to peel off my coefficients here, so that's 1 over 2 k plus 1, 3 and 0, and 2, 1 and k minus 1. Okay, and this is going to be x, y, z. So this matrix multiplied by this here is going to give us this left hand side, and that's going to be equal to, and I've got 5k3. Okay, right, so what we're trying to show, in order for this to not have a unique solution, we don't want there to be an inverse that exists for this particular matrix here. So that means the determinant of this matrix would need to be 0. So I'm going to say that the determinant of this is equal to 0. Okay, once we've got this far, we now need to work out what the determinant of this would be in terms of k. So I'm going to just split this up into, I've got 1 times the determinant of this here, and then I'm going to go this way actually, so I've got -2, so that's going to be a positive, so plus 2 times the determinant of this here, so I've got k plus 1, 2, 0, k minus 1, and then I've got plus k times the determinant of this bit here, which is k plus 1, 2, 3, 1. Okay, and I want that there to be equal to 0. So I'm just going to crunch through this for you, and this simplifies to this here. I can now factorize this, so this is going to be 3k take away 5 k plus 1 is equal to 0. So that means I've got two values of k. I've got k is equal to, and that's going to be 5/3, and I've got k is going to be equal to -1. Okay, I'm just going to tidy up my work. Okay, so there we go. We've got k is equal to 5/3 and k is equal to -1. For part B, we need to show that the system of equations is consistent for one of these values of k, but inconsistent for the other. So for part B, I'm going to use the 5/3 first. So when k is equal to 5/3, what I'm going to do is I'm going to write this in augmented matrix form, and I'm going to substitute the 5/3 into it as well. So I'm going to have this as 1, 2 and 5/3, and then 5. Okay, and then I'm going to have 5/3 plus 1, which is 8/3, and 3, 0, and 5/3, and then I'm going to have 2, 1, 5/3 take by 1 is 2/3, and 3 over here. Okay, so this here is called augmented matrix form. I've got my left hand side over here, my right hand side over here. I'm now going to, because I don't like the look of all these thirds in here, I'm going to put it together. I'm going to rewrite this with instead of the thirds, I'm going to multiply each row by 3. Now remember, these are just equations at the moment. That just says x take away 2y plus 5/3 z is equal to 5. So if I multiply this by 3, I'm not actually changing the equation at all. So that's going to be 3, -6, 5 and 15. And I'm going to have a line there, so then I'm going to have 8, 9, 0 and 5, and over here I'm going to have 6, 3, 2 and 9. Okay, right, so for this next part, what I'm going to do is I'm going to write this in row echelon form. So I need to get a triangle of zeros in my matrix. So I'm going to aim to make this part of my matrix, of my augmented matrix, 0. Okay, so first of all I need to change this to 0, and once I've got this to 0, I should be able to change this here to 0. I've chosen this bit here because I've already got a 0 there, so it will make it nice and easy for me. Okay, so in order to make that 0, I need to replace this whole row. So I'm going to get a new row 3. So my new row 3, that's what that says, and that's going to be I'm going to get that from times in this by 5 and taken away 2 lots of the top one. So it's going to be 5 lots of my original row 3 take away 2 lots of row 1. Okay, so I'm not touching my top 2 rows, so that can stay as it is. But this bottom row has now changed because I've multiplied it by 5 and taken away 2 lots of the top row. So 5 lots of 6 is 30, take away 6 is 24, 5 lots of 3 is 15, take away 2 lots of -12 is 27, 5 lots of 2 is 10, take away 2 lots, that's going to be 0, and that's going to be 45 take away 30, which is 15. Okay, so what I've got here now is I've got 8. This here is saying 8x plus 9y is equal to 5, and this here is saying 24x plus 27y is equal to 15. And you might already spot that the second equation, sorry, the third equation is 3 times as much as the second equation, so we can already see that we've got consistency here. Just to finish this off though, I'm now going to take away 3 lots of row 2 away from row 3, so my new row 3 is now going to become row 3, which is this row here, take away 3 lots of row 2. So again, this row isn't going to change, this row isn't going to change, but now my row 3 is going to become 24 take away 3 lots of 8, which is 0, 27 take away 3 lots of 9, which is 0, that's going to be 0, and 15 take away 3 lots of 5 is going to be 0. And because we've got zeros along the bottom row, we're saying 0 of x plus 0 y plus 0 z is equal to 0, which is always going to be true. So we can say for this reason this is going to be consistent. Okay, now we need to investigate what's going to happen to what's going to happen when k is equal to 1. So I'm just going to tidy up my work again. Right, so when k is equal to -1, I'm going to write this in augmented matrix form again. So I'm going to get 1, -2, -1, 5. I'm going to get 0, 3, 0, -1, and 2, 1, -2, and 3. Okay, so what I want to do is I want to get a triangle of zeros again. Now we may spot that there's an easier way of doing this, but I'm going to stick with the way that I've done it so far. So we'll try and get a triangle of zeros over here this time actually. So I'm going to start off by making that 0 by taking away 2 lots of the top row from it. So my new row 3 is going to be equal to row 3 take away 2 lots of row 1. So it's only row 3 that's going to change. That will be 0 and 1, so that's 5, 0 and -7. Okay, so now we can go further than this, but what I'm going to do is I'm just going to write down the 2 equations here, because it looks to me that they're going to disagree with each other. So I'm going to write down 3y is equal to -1, which leads me to y is equal to -3rd, and I'm also going to write down 5y is equal to 7, which would lead me to the solution y is equal to 7/5. So -7 and -7/5. Okay, these two don't agree with each other, so that tells me that this system of equations is going to be inconsistent. Okay, because these two don't agree with each other, then that's telling me that this is going to be inconsistent, so there aren't going to be any solutions to this equation, to the system of equations. Okay, so we found that it's consistent when k was equal to 5/3, and when k was equal to -1, we found that this system of equations was inconsistent. Okay, I hope you found that useful, and I look forward to seeing you again next time.